Good morning, it's me, Mr. Tree. I'm back for the second part of this video in which I'm going to go over this whole idea of what's called similar triangles and indirect measurement. So in the first video, yesterday, you'll see that we went out there in the middle of the afternoon and we did a few measurements with shadows of students versus the shadow of our flagpole of our school. And the idea is that if we use what's called similar triangles, we can figure out how tall the flagpole is. So if you want to know how tall the flagpole is, you got two options. Obviously, we can climb the flagpole, which is not going to happen, not at least for me. And then we can do something called measurement it's called actually indirect measurement. So what we're looking at when we do this is basically we're looking at similar triangles. If you look at each of the measurements I made, I had a really tall student, and I measured him at 76 inches tall, and his shadow on the ground when he stood next to the flagpole was 94 inches. Then I had another student who was 66 inches tall, and the shadow that she had on the ground was 82 inches. And then the third student was 62 inches tall, and her shadow was 79 inches. Well, we're creating a situation of what's called side angle side similarity. All three students stood at 90-degree angles, so we had an angle in common for all three kids. And the flagpole is also at 90 degrees. Now, the proportion that represents their height versus their shadow creates a side angle side, because each of these proportions should be the same theoretically. They should be very close. There is some margin of error as I'm trying to measure shadows out yesterday on a cloudy day where every other minute a cloud will come by and mess up my measurement. But to the nearest amount, we're going to say that these are going to meet the criteria for side angle side. So what I'm going to do is use similar triangles to figure out how tall is the flagpole. So I can start by making a proportion. So let's say I want to go with, I'll take this kid here. So I'm going to do this 3 times so that we get 3 results, and then we can see that there might be some slight variation. And that's probably more on me than anything else. It's probably me just my measuring. So if I look at this one, I got a flagpole right here, and let's say X is the height of the flagpole. Well, I'm going to create a proportion. So I'm going to say X is the flagpole, 76 is the student. 349 is the flagpole shadow, 94 is the student shadow. All right, so I get my calculator, I'm going to cross multiply. I'm going to go 94 times X. Then I'm going to go 76 times 349, and I get 26,524. If I divide that by 94, I get 282 inches. I'm going to round off 282 inches. So that's using this student. If I do that same process with each one of these students, I should get relatively close to the same answer. I know it's going to be a little bit different because I, again, probably made a mistake. I had a hard time getting the most accurate measurement of the shadow. They were in the grass, unfortunately. And then the last student, I think this is the one I had the hardest time with, because right when I was trying to measure her shadow, I ended up with a cloud that came by, just kept messing it up in the grass, made it really hard to figure out. So let's double check that one. So I got So, like I said, I was pretty sure, and you can see in the video that when I was trying to measure it, it's just when I was measuring her, I had a cloud to contend with. So I think her shadow is what I screwed up. I think her shadow was probably a couple inches less than I thought it was, which would probably bring this a little bit closer to the other two values. But either way, even on like I said, even with a rough estimate, I can figure out that in all 3 cases, it looks like our flagpole is roughly around 280 inches. And if I was to convert that 280 inches
into feet because there are 12 inches in foot. It shows that our flagpole is approximately 23 feet. And again, that's called indirect measurement. They use this in all kinds of applications to do with like surveying and things like that. Like if you're trying to figure out how far it is across a lake, you can use indirect measurement versus actually swimming across the lake with a tape measure in hand. I can't imagine doing that in Florida. Anyways, but that's it. That wraps it up. Thank you.